In section chapter 3-2, we are going to be looking at solving system of inequalities now by graphing. So it's kind of like solving the system of an equation or equations, but this time it's going to be inequalities. So what do? Well, here's an example. If we're going to solve the system of these two inequalities, we first have to graph them. What do they look like? What does y greater than 2x minus 4 look like? Well, first you pretend it's an equation, right? Instead of the greater than, less than, you put an equal sign. So you graph it. So y equals 2x minus 4. Let's just see if without a calculator we can do that. So negative 4 is your y-intercept. So 1, 2, 3, 4. There. So that's the first point you place. Here's your slope. 2 divided by 1. So you rise 2, run 1. So I'm going to rise 1, 2, run 1. Rise 2, run 1. See, there's another dot. 2, 1, 2, 1, etc. So I think you see the line there that formed. So I graphed it. Now, why did I do it dotted and not like a solid line? Well, if you notice back to the equation, it doesn't have an equal sign. So it's not equal to the line. Think of the border wall. You can kind of get all the way up to the border wall, but don't cross it, right? Like it just, you can, don't even touch it because some places has like electric current or whatever. So it's the same thing here. You can get all the way up to the wall, but you're not on it. You can't be on the wall or beyond it. So therefore, y is any number that's greater than that particular boundary, okay? So since it doesn't have an equal sign, you make it like dashed. Now, notice the other one. The other one does have a solid line, so it can equal to that line. And if you notice, here's the one I drew for that. This is y equals negative 0.5x plus 3. But it's not an equal. It's a less than or equal to. So where are all the points that are less than? Well, less than normally goes here. So notice what I did. What I did was here's my first line. Here's my second line. And we need to find the spot where they overlap. Now, if you notice, for this one, they wanted the y's that are greater. Well, this is the line, right? So where are y's greater? Up here, right? Because you see that they're greater, greater, greater. So if you notice, I colored that region with that it was, I think, a yellow marker. It looks a little green here. And then region 2, this is the line I'm talking about, and it says the y's are less than that. So y's less are down here at the bottom, and I colored that with that pink. Well, do you see where green and pink are separate, but there is a spot where they're checkered and they overlap? This region 3 that is created by that is the part of the solution for both of those. So any point in here in this region would be a solution to these two inequalities that I'm giving you. So now we're dealing with regions instead of actual like being on a line or touching or intersecting, etc. Now it's this area that if any point is in this area, for example, if I have a point here, right there, then it's considered as being part of the solution because it's both under this graph and it's on top of the other. So now let's look at kind of the same idea where you have, let me just fix my screen real quick. So if you notice, your packet, the first slide will give you kind of the same idea, give you some equations for you to graph. Notice how this one has an equal, the bottom one doesn't. So one is solid, one is dotted line. And so you're trying to look for the region where both of them intersect. So notice how they did the same thing here. You have the first region of one of the equations. You've got the second region for the second, and then their overlap is what you are looking for. So apparently here they overlap in region 2 because yellow and blue make green, right? So that was kind of clever of them to do that. So if this is the overlap, that's region 2, then any point in here is a solution to these two equations. So it'll make these two equations true. So go ahead and go through some of these examples. And this is a very interesting one because if you notice, look at that. I immediately saw these are parallel lines, -3/4 and -3/4. but one is greater than and one is less than. So then you've got the shading accordingly. And then of course they're both equal. That's why they're both solid lines. So that's kind of interesting to look at some of those. Now, the question is, what is the solution? What point do these have in common? Well, again, they're parallel. So they shouldn't have any points in common, right? Because we already said parallel lines don't touch, etc. So therefore, check this out. The solution set is not 0, because 0 would mean that they touch at the point, something having to do with a 0. The solution set is empty. So therefore, they use the correct symbol for that in that situation, because there is no point they have in common. So again, then you'll have some extra examples to practice with. If you notice this example here, they not only give you 2 equations, now they give you 3, and it creates a triangle. So it just, here's the answer. You can kind of look at the question, try to do it on your own, and then of course the answers are there for you. So the same thing with a study guide. This is really meant for you to practice. There's not a lot of problems, so I'm going to let you go ahead and do that. Maybe I'll just do one real quick, just to kind of get you started. So let me go ahead and just do question number 1. So, well, you know what? Let's do question 5, since it has fractions. I know a lot of you don't like fractions for some reason. All right, so if I'm going to do question number 5, it's already in slope-intercept form, which is what I wanted. And so let me go ahead and start graphing. So the first one, I'm going to do, let's activate the red pen. Okay, so we pretend that there is an equal sign. So we're going to actually graph y equals x over 3 plus 2. So I know that this is my y-intercept, and so I'm going to go ahead and choose that first. So 1, 2, this is the spot where the first graph crosses. And if you notice, I'm going to put a 1 here in front of the x, because there is no number, but there is actually the number 1. And so now I can see clearly my slope is 1/3. So if my slope is rise 1, run 3, then I can just do that. So I go up 1 and run 1, 2, 3. Up 1, 1, 2, 3. So now I can graph the line that it looks like it's forming. But we are dealing with an inequality, so I need to find all the points that are less than, so all the y's that are less than that thing. However, let me just remind you of one thing. This does not have an equal here or here, and so therefore the line is not solid. So instead of doing a solid line, I'm going to do a dotted line all the way through. And so all the points, all the y's less than this thing are of course, less than, it would be smaller. So this y is 2. So I'm looking for a y of 1 of these. So the area in question is down here. That's y less than that equation. Now let's graph the other one. For the other, let me choose a different color. And so to graph this, I see here that my equation is going to have a y-intercept of 1. So we're looking at a y-intercept of 1 here. And my slope is interesting because it is -2. And so I need to turn that into a fraction. So that's my slope. So I'm not going to go up 2. I'm going to go down 2 because of that. So go down 2 over 1, down 2 over 1. The same thing, there is no bar here, so it's not equal to it. So I'm just going to do my dotted line going through there. So if you notice, there is an area where both of these overlap. So I'm just going to shade that, which is this right here, that they both have in common, because now I'm looking for the y's less than this equation. So if this is one of my y's, here are the points less, so it's down here. So that is your answer right there. It's this region that they have in common. And if you continue looking at your study guide and intervention, you have some more practice problems. Let's just do maybe one more here. So let's try the first one. The first question tells us, get it there, that to solve each system of inequalities by graphing. Okay, same thing. Now, I'm going to go to this one because it caught my attention since it looks like a HOI, where it's a y equal to something, or in this case, y greater than or equal to 1. It's a horizontal line, so I just need to find the y is equal to 1, and I draw my horizontal line. Now, notice how I'm drawing it solid. The reason I put it solid is because you do have that little equal there at the bottom. All right, so then there's my solid line, and now we need to fix this a little bit because it should be like a y equal mx plus b format, your slope-intercept format. So let's try to do stuff here. So let's move the 1 this way so it becomes a -1. So then I end up with y is less than negative x minus 1. So now it's a lot clearer to see what is what, right? So this is my y-intercept, so I'm going to cross at -1. Now notice that this is just less than, not equal to, so I'm going to draw a dotted line. So what's my slope? Well, there's no number, so I'm going to put my 1 in there and 1 over 1, but this time it's negative. So since it's a -1, I'm going to have to go down 1 and over 1. Down 1, over 1, down 1, over 1, and I think you see the pattern emerging. So, clearly a point of intersection that they have in common. There. And so remember, this one though didn't have, so I'm going to do dotted lines instead of a solid. All right, so now let's see what areas we're looking for. So in this particular one, my horizontal line, I need the y's greater than 1. So here's 1, so it's all of these y's. So the area in question is up here. And for the other one, for this equation, which is this one right here, I'm looking for the y's less than that. So then here's 1y, it's here, less, less, less. So then it's this area down here. And if you notice the area where they overlap, I'm looking at that space right there as being the solution.